Hi guys. So here actually we discuss the top-down approach, right? We actually discuss like the overlapping problems, and then we actually introduce an array. And what we are doing before actually jumping to a recursive function copy solution, right? Before jumping to, we are looking up into the memory, right? So here we just introduce in memory in between. So we are looking into the memory. If that thing is present in the memory, we are actually returning it. If not, then we are calculating and putting in the memory. So this is the top-down approach. So now we'll discuss the bottom-up approach into this video. This was the top-down approach. So same thing, like if you see the problem statement, right? And so top-down approach, we actually come from the last value to the lowest value. This is the top-down approach. And bottom-up approach will start from the basic, and then we go till further. So what I'll do, bottom approach. So you're seeing like this, like the result of this thing is the sum of last two. The result of this is the sum of last two. The result of this is the sum of last two. That we have generated. We have generated a recursive, like a recurrence relation, right here. There's the sum of last two, and we generated the base condition here. This are the base condition. So with the help of this two, we'll write the bottom up approach. So it's very simple. Like what you need to do, like first, whatever is your maybe solution, right? Any function like ABC, I'm giving you the name, and here n is given, right? So firstly, you will apply your base condition, right? The base condition is same condition. If n is less than equals to 2, you will return n here, right? This is your if. Now this is your if. Now what you'll do, you will initialize a memory. So that is actually a cache, or you can call it as a DP or whatever. That is a array. So we'll make a size of whatever n is given plus 1. We'll just make one more. And what we'll do here, you actually initialize it, right? So that's the turn. You actually initialize it. So what you'll do, you know all the base condition, right? You know all the base condition from this, like 0 we have 0, 1 we have 1, 2 we have 2. So dp, you will do dp of 0 equals to 0, dp of 1 equals to 1, dp of 2 equals to 2. So now, like whatever is your array, right? This is your array. This is a 1D array. I'll explain to you like the 1D and 2D array into different lectures. So what we have done, we have initialized it 0, 1, 2. Now what we'll do, we'll run a loop. Like in this approach, we run a loop like in bottom approach. If you haven't aware of this condition, like this approach, I have explained in the Fibonacci series. You can go that video, visit that video. In that I have explained the bottom up approach. So what we'll do, like till 2 we are short, right? So we'll run a loop from 3. So when I equals to 3 and I is less than equals to n, and then I plus plus. What we'll do, simple dp of I, same, the recursive, this is this recurrence relation, right? The dp of I equals to n minus 1 plus n minus 2. The dp of I equals to dp of I minus 1 plus dp of I minus 2. So this is the loop. Once we are done with the loop, actually you have populated. So what we have done here, so we have this initialization done. Now we are running from 3. So the value of 3 is be I minus 1 plus I minus 2 means 2 plus 1, that is 3. That's how we are gradually increasing the array size. Now we are not calculating all the sub-array, right? To calculating of 2, we are not going till 1 and 0 and so on. We are just seeing the last 2. To calculate of this, we'll just add last 2, 5. To calculate of this value, we'll just add the last 2, that is 8. To calculate of this, we'll just add the last 2, that is 13, right? And whatever is the n is given, you just return it. If n is 6 is given, you just return n is 6, that equals to 13. If n is 5 given, like if they ask n is 5, what is the value of 5? Equals to 8. If they ask n of 4, you just return whatever the value at 4, that is 5. Next is like 13 and 18, that is 21. So if they ask you n of 7, you just return 21 from this array. You don't need to recalculate all this n of 6 again, n of 5. You already have a result and we have saved it. So at last you just need to return dp of n. So this is the bottom of approach. It's simple like the another approach of the DP. Okay. In the next lecture, I will code this. I mean the coding part is done. I will just try to code this into the Leet code and try to run this if everything is fine or not. Thanks.